Now in our last part of our lesson on solving polynomial equations, we'll look at applications. There are many different applications we can use polynomial equations to help solve. One pretty substantial application is what we call projectile motion. Projectile motion is a term that describes any object that we throw or drop or launch or fire. If you take physics, you'll learn a little bit more as to why this is. But to give you a very basic rundown, here's my projectile motion equation. For this particular situation, we have a model rocket, small rocket. We're going to launch it at 48 feet per second. So see that number 48? That's showing up in my equation, 48t. The rocket's height, h, after t seconds is given by my equation, h equals 48t minus 16t squared. This minus 16t squared part, that's the effect due to gravity. So the minus 16 minus means it's coming back down to the ground. And this is just the effects of gravity. To understand a little bit more about that negative 16t squared, physics will explain it a little bit better. You talk a little bit about it in calculus as well. We're going to take this equation that's describing the height of my rocket, and we're going to try to answer the question. So the question that we have, after how many seconds will the rocket strike the ground? So how many seconds means we're looking for t. We're looking for the variable t. And the rocket striking the ground, what does that refer to as far as h is concerned? If the rocket strikes the ground, its height would be 0. So we're going to take 0 and replace the h in our equation with 0. And in doing that, we now have a polynomial equation that we can solve. It's equal to 0. We're going to try to factor it. So here we go. 48 and 16 have a 16 in common. So I'll write 16t there. 16 times 3 will give me 48. 16t times t will give me t squared. So I'm just factoring out that greatest common factor. I don't have any higher powers of t in my parentheses, so I can't factor it anymore. I don't have a special product or anything. And now I have my equation factored. I can set it equal to 0. 16 won't equal 0, so I don't have to worry about setting 16 equal to 0. But t equal to 0 and 3 minus t equal to 0, we should solve for t. T equal to 0 is done. 3 minus t equals to 0. I like to add what's negative so that I have them positive. So add t to both sides, and I get 3 equals to t, or t equals 3. Remember, it does not matter on which side of the equation our variable is as long as it's isolated. It's okay to be on the right. There's nothing wrong with that. And so we have two answers. But let's talk about these two answers. When we refer to a real-world situation like this model rocket launching, sometimes both answers will answer the question, and sometimes both answers won't answer the question. Even though we get two answers, we always need to go back up to the original question and figure out whether both of them work, or just one of them, or neither of them. After how many seconds will the rocket strike the ground? We've got a rocket that we're going to propel up in the air. We shoot it up into the air, and it's going to go up, and then it's going to come back down. Splat. T equals 0 is when the rocket starts. I want to know after we launch it, how many seconds will it take? So t equals 0 is not the answer to my question. And let's see, does it make sense that 3 seconds later it would strike the ground? That seems pretty reasonable. So answering the question after 3 seconds. All right, let's try one with a little bit of geometry. A frame surrounding a picture is 2 inches wide. The picture inside the frame is 7 inches longer than it is wide. If the overall area of the picture and the frame is 198 square inches, find the dimensions of the picture inside the frame. And first we need to determine the lengths of the picture and the frame by filling in these white boxes that are here. There's a lot of words and there are a lot of numbers. Let's see if we can put them together. So a frame surrounding a picture is 2 inches wide. We have that part taken care of with the 2's that are showing up in the picture frame. So this is referring to this distance here and this distance here. Picture's not drawn to scale. 2 inches wide, 2 inches wide. Okay? The picture inside the frame, that's represented by the darker rectangle or the purple rectangle, is 7 inches longer than it is wide. So we're going to let the width be x, and if it's 7 inches longer than it is wide, then what do we need to add to x? Right, we need to add 7 to it. So we get x plus 7 for the inside picture and x for the width. Before I move on to the next question, because that's talking about area, that's something different, let's take a look at the outside. So the picture plus the frame. If I have my picture here, how much more am I extending it by with that 2 inch wide picture frame? Not 2, because I have it on both sides. I'm extending it by 4. 2 plus 2. So notice all the way across. 2 plus x plus 2. X plus 4. And then how about the entire picture plus the frame with its length? So we have x plus 7 up here. And now I'm going to go 2 more inches on either side. So I have x plus 7 plus 2 plus 2. So x plus 7 plus 2 will give me 9, plus 2 more will give me 11. Now we can talk about the area. The overall area of the picture and the frame is 198 square inches. How do I find the area of a rectangle? Do you remember? Length times width. So we're going to take the length of my big rectangle and the width of my big rectangle and multiply them together. Length, x plus 11, times width, x plus 4, and that has to equal 198 square inches. This sets up our polynomial equation that we're going to have to solve. Now here's where we have to be careful. This equation does not equal 0, so I do not get to set these factors equal to 198 and try to solve them. That doesn't work. I have to have my equation equaling 0, so I'm going to have to multiply this out. Let's do that. I like using the box method, so I'm going to use the box method because it works all the time. X plus 11, x plus 4, x times x is x squared, x times 11 is 11x, x times 4 is 4x, and 4 times 11 is 44. So on the left side I can replace the x plus 11 times x plus 4 with x squared plus 11x plus 4x plus 44 equals 198. I'm going to subtract 198 from both sides because I need this equation to equal 0. So I'll do that, and then I'll also combine like terms here. X squared plus 15x minus 44 minus 198 gives me 154. So I really have to solve x squared plus 15x minus 154 equals 0. No greatest common factors, so we're going to use the AC method. A is 1, C is negative 154, so we need two numbers that multiply to be 154 and add to be 15. This might take us a little while. 154 is a big number. I need to add to positive 15, so I'm going to have the smaller number be negative. 2 will divide. And we can always pull up that calculator. 154 divided by 2 will give me 77. 154 is not divisible by 3, not divisible by 4, not divisible by 5, not divisible by 6. I'm just punching in numbers, right? I'm ignoring the negative sign right now because that just adds an extra layer. I just want the numbers, and then I can figure out which one should be negative later. 154 divided by 7 is 22. Negative 7 and 22. So 154 divided by 7 will give me 22. I'm going to take the smaller number and make it negative. Negative 7 times 22, negative 154. Add them together. Negative 7 plus 22. I get 15. That's the pair I need. So middle term gets split. Negative 7x plus 22x. We'll bring the rest of it down. Factor by grouping. Group the first two. Group the last two. X squared and 7x have an x in common. X times x is x squared. X times negative 7 will give me negative 7x. Bring that plus sign down. 22x and 154. We determined that 22 will divide 154, so we're going to pull that 22 out. 22 times x will give me 22x. 22 times negative 7 will give me negative 154. Equals to 0. I have the same factor, x minus 7. X plus 22 goes in its own parentheses, equal to 0. Now I've got my left side factored, set each factor equal to 0. Solve for x. I can add 7 to both sides. X equals 7 is one solution. Subtract 22. X equals negative 22 is my other solution. But this is a word problem, so I shouldn't circle them just yet. I should leave them uncircled. I need to go all the way back to my original problem. I'm so sorry, it's so terribly small. But my original problem says find the dimensions of the picture inside the frame. So I just found two answers for x. I need to determine if both of them are valid or if only one of them works, and then I can find the length of the picture because I know the width. So coming back over here, x is 7 and x is negative 22. Does a picture with a length of negative 22 inches make sense? No. We can't have negative distance, negative length, when we're measuring an object. It doesn't make sense. Distance is positive. So we're going to cross out that negative 22. It's just an extra solution. And this happens when we're using math to model real-world stuff. The polynomials are allowed to go outside the constraints of the real world. So negative values for x can happen for a pure polynomial equation, but in some instances of the real world, negative x values don't make sense, like they don't here. That just means that x should equal 7, and we're going to use x equals 7 and try it up here in our picture frame and see if it makes sense. So if x equals 7, then x plus 7, 7 plus 7, will equal 14. So we end up with a 7 inches by 14 inch picture frame. And let's double check and see if this will cause my area with the picture frame to be 198 square inches. So I'm going to do a quick check. X plus 4, 7 plus 4 will give me 11. And then x plus 11, 7 plus 11 will give me 18. I can check 11 times 18 on my calculator, and I get 198 square inches, and it works. I used the 7 plus 4 and the 7 plus 11 because the 198 inches refers to the picture plus the frame. So I had to add on the extra 2 inches on every side for the picture frame.